It's me again. Today I'm going to explain both variable scope and scope resolution. Variable scope is where a variable is both visible and accessible. With scope resolution, when we're using a variable, there is a certain order known as the LEGB. Me again. Today I'm going to explain B rule, in which we locate that variable. Local, enclosed, global, built-in. We'll get to this momentarily. Let's begin with variable scope. I have two functions, function 1, function 2. Within function 1, A equals 1, then we print A. Within function 2, B equals 2, then we print B. If I were to invoke these functions, let's invoke function 1, then function 2. We would print 1, then 2. Variables declared within a function have a local scope. Variable A is local to function 1, variable B is local to function 2. Within function 1, if I were to print B, and function 2, if I were to print A, we would run into a name error. Name B is not defined. And the same thing would apply with A. Functions can't see inside of other functions. Imagine that we're function 1. This is our house. We can see everything that's going on inside of our house. But function 2 is our neighbor's house. We can't see what's going on inside of our neighbor's house. We have no idea what B is. With function 2 has no idea what A is. That's where variable scope comes in. It's where a variable is visible and accessible. Functions can't see inside of other functions, but they can see inside of their own function. That's why we sometimes pass arguments to functions so that our functions are aware of them. Using this concept, we could create different versions of the same variable. Let's rename A to be X and B to be X as well. Then I will print X. We have two different versions of X. A local version of X found within function 1, and a local version of X found within function 2. Whenever we utilize a variable, we will first look to see if there's any local instance of that variable. If there isn't, we would move to the enclosed scope. With an enclosed scope, one example is when you have a function declared within another function. I'm going to place function 2 within function 1. This is allowed in Python. This is a more advanced concept. We'll cover this more in the future. So I'm going to eliminate this print statement. Let's get rid of function 2. At the end of function 1, we will invoke function 2. Like I said, it's pretty complex. We won't be using this until much later. Within function 2, if I was to print X, we would use the local version, where X equals 2. If I was to eliminate this variable declaration, we would use the enclosed version instead, where X equals 1. There's an order of operations. Use any local variables first, then enclosed variables. We're printing X within function 2. Since X wasn't found within the local scope, we would use X within the enclosed scope. But like I said, that's a more advanced topic. You should at least be aware of it. Let's move on to the global scope. Global meaning outside of any functions. I will eliminate these variable declarations. Within function 1, we're printing x, and within function 2, we're also printing x. I will declare a global version of x, where x equals 3. X is outside of any functions. When I run this program, we're printing 3 twice. Once for function 1, and once for function 2. There's no longer a local version of x for both of these functions. If there were, we would end up using these local versions instead. Function 1 prints 1, function 2 prints 2. If there's no local version, as well as no enclosed version, we would move on to the global version, where x equals 3. Last in our order is built in. I think what we'll do though is from math, import e. E is an exponential constant. I'm going to print what e is. E is 2.71. E is built in. I will create a function to print e. Define function 1. All I'm doing is printing e. Then we should invoke it. Invoke function 1. If I was to set e to be a different value, like 3, what we're doing technically is creating 2 different versions of e. Variables can share the same name as long as they're within a different scope. We have a built-in version of e and a global version of e. If I was to print e now, it would print my global version, because using the LEGB order, we would first look for any local version of e, then enclosed version, then global, which we do have one of, then lastly built in. Alright everybody, so in conclusion, variable scope is just where a variable is both visible and accessible. Python has a scope resolution order, LEGB. If we're using a variable, we will first look in the local scope for that variable. If we don't find that variable in the local scope, we will move over to an enclosed scope, then global, then built-in. We will have more practice with this in the future. And well everybody, that is both variable scope and scope resolution in Python. Hey everybody. So today I got to talk about this if statement. If dunder name is equal to a string of dunder main. When you see this if statement, it's usually followed by a call to a function named main, or something similar. A majority of the driving code behind a program is usually found within some sort of main method. When you see this if statement, basically speaking it means that this script can be imported, or it can run standalone. Functions and classes in this module can be reused in other programs without the main block of code running. Sometimes you would like the functionality of a program without executing the main body of code. A good example could be a library. In a Python library, we would like to import some of the useful functions, such as the math module. But if we were to run that library directly, instead of importing it, we could instead display a help page. But if we're importing that library, we don't necessarily want to display that help page, only if we're running it directly. In many Python scripts, you'll see the statement of if dunder name is equal to main. If we're not running this program directly, don't do it. In this example, we're going to delete our main Python script. Be sure to recreate it at the end of this topic in case I forget to mention that. We will create 2 new scripts. Go to File, New, Python file, Script 1. File, New, Python file, Script 2. We have to add new run configurations for Script 1 and Script 2. So if you go to the top, go to Run, Edit Configurations, we will add a new run configuration. Select Python, select a new script path to script 1. OK, apply. Again, we have to do this with script 2. Add, Python, select a script path of script 2. OK, apply, then OK. Using this drop-down menu, we can select which run configuration we would like. Would we like to run our main Python file, but we have deleted it? Do we want to run script 1 or script 2? For the time being, we'll select script 1. Within script 1, if I was to print, then call the dir function, dir meaning directory, Python has all of these built-in attributes. If you're not familiar with object-oriented programming, for now, think of an attribute as a variable. Dunder name is a special type of variable. Dunder meaning double underscore. If I was to print what's contained within dunder name, we would receive a string of dunder main. That's why in a script you may see the statement, if dunder name is equal to a string of dunder main. If so, then you usually call a function named main to start your program. I'm going to undo that. So let's import script 2. From script 2, import everything. Asterisk means everything. Within script 2, I will print dunder name, and we'll see what's within it. Again, I'm running script 1. Within script 2, dunder name is equal to a string of script 2, the name of the Python script. However, within script 1, dunder name is equal to a string of dunder main. This means I am running script 1 directly. Let's delete this import. Then go to script 2, import script 1. From script 1, import asterisk meaning all. We're now going to change our run configuration from script 1 to script 2. We are running script 2 directly. Now, dunder name within script 1 is the name of the Python script, script 1. Dunder name within script 2 is now dunder main. So by adding this if statement of dunder name is equal to dunder main, we can check to see which file is being run directly. If dunder name equals dunder main, we will call a function of main to contain the main body of our program. But we need to define this function. Define main. Our main function will contain the majority of our Python code, anything that's not already within a function. So let's print, this is script 1. Then we'll define another function of favorite food. We will have one parameter of food. Let's print the following message. I'll use an F string. Your favorite food is, add a placeholder, add our parameter of food. Within our main function, let's call the favorite food function. Pass in your favorite food as a string. I'll type in pizza. Then let's print the word goodbye. We're going to run script 1. Run it. Here's the result. From the top down, all of our code is within functions. We skip over it because we're not calling it quite yet. The first thing we do in this program is check this if statement. If dunder name is equal to dunder main. Are we running this program directly? Which we are. We're running script 1. If so, call the main method to start the program. We print, this is script 1, your favorite food is pizza, goodbye. Now I'm going to go to script 2. Delete our print statement. Change the run configuration to script 2 and run it. Nothing should happen. That's good. Now, if we were missing this if statement of if dunder name is equal to main, then we delete our main function. Here's what would happen. We're importing script 1, but we're running script 2. This is script 1. Your favorite food is pizza. Goodbye. I don't want this code to execute. We're not running it directly. That's why we have that if statement. If dunder name is equal to main. I only want to run this code if we're running it directly. So what we'll do within script 2 now is define a function of favorite drink. There's one string, we'll add a place. Within your color script, we're running from script, but you don't import it without this body of code running. Equal to it. This could be a Python library. You can be imported. A more practical example of this could be a Python library. Dunder name equals dunder. No global variable. Purpose of if buddy. This is meant to in this video equals dunder main in Python. Hey, what's going on everybody? So in this video, we're going to create a very simple banking program using Python. This is meant to be more of an exercise to get us used to working with functions. When creating a project, I like to divide that project into smaller sections, then handle them one at a time. So we'll do that by declaring all the functions we'll need first. With the banking program, we'll need to show a user their balance. We'll define a function to show balance. For the time being, I'll write pass just as a placeholder. We'll need to make a deposit, define deposit, make a withdrawal, define withdraw. Near the end of this project, we will be creating a main function and placing the main body of our code within it. We'll handle that near the end, just to contain everything. We have our three functions. With our banking program, we'll need to show a balance, make a deposit, or make a withdrawal. What are some variables we'll need? Well, we'll need a balance, which I will set to be 0 initially. I will also create a boolean of is running. This will be true. If at any time we set is running to be false, we'll exit the program. So with the majority of our code, we'll place it within a while loop. While is running. You can check to see if this is equal to true, but since this is a boolean, that's not necessary. We will just say while is running. If is running becomes false, we'll exit the while loop. Within our while loop, we'll print some sort of welcome message. Let's print banking program, then list some options. Let's print 1, show balance, 2, deposit, 3 will be withdraw, 4 will be exit. Afterwards, we will set a choice variable to equal some user input. Input, enter your choice 1 through 4. We're encouraging a user to type in a number 1 through 4 to select an option. Do they want to show their balance, make a deposit, make a withdrawal, or exit? We'll add a few if and else if statements. Let's check to see if the user's choice is equal to 1. And that is a string of 1. Our user input is a string data type, unless we were to typecast it to something else. If our choice is equal to 1, we will call the function to show balance. Else if our choice is equal to 2, we will make a deposit by calling the deposit function. Else if choice is equal to 3, we will call the withdraw function. Else if choice is equal to 4, that means we would like to exit. So we need to exit this while loop. We can do that by setting our variable of is running, is this program running, equal to be false to exit. If somebody types in some input that's not valid, we can handle that with an else statement. Else, let's print that is not a valid choice. Okay, let's see what we're working with currently to test everything. We haven't written anything within these functions yet. show balance, deposit, or withdraw. So we can type 1, 2, 3, and 4 to exit. Processed finished with exit code 0. So we can exit the program, we just have to select option 4. With this else statement, this will execute if we type in something besides the numbers 1 through 4, because there's no other options left. So to test that, enter your choice 1 through 4. I'm just going to type the word poo. That is not a valid choice. So we know that the else statement is working. Once we exit the while loop, let's print a message that says, "Thank you, have a nice day." If I was to type 4 to exit, we should exit the program. "Thank you, have a nice day." Let's make that H capital. Now we'll work on our functions, beginning with show balance. Currently these two variables are global. We don't need to pass them as a parameter to these functions quite yet. We will be enclosing all of this code within a main function. We'll handle that later though. So with show balance, all we're going to do is print, I'll use an F string, your balance is, add a $, or other unit of currency of your choosing, add a placeholder, our balance variable, and let's see what we have. I will type 1 to show balance. Your balance is $0. I'll display our balance with 2 decimal places after. I will add a format specifier. I'll do one thing, add a placeholder, our balance variable, and let's see what we have. So close, work on our function today. Let's make that H cap. Currently these two a that says "Thank you, have a nice day." If I was to type 4 to exit, we should exit the program. "Thank you, have a nice day." Let's make that H capital. Now we'll work on our functions, beginning with show balance. Currently these two variables are global. We don't need to pass them as a parameter to these functions quite yet. We will be enclosing all of this code within a main function. We'll handle that later though. So with show balance, all we're going to do is print, I'll use an F string, your balance is, add a $, or other unit of currency of your choosing, add a placeholder, our balance variable, and let's see what we have. I will type 1 to show balance. Your balance is $0. I'll display our balance with 2 decimal places after. I will add a format specifier after balance, colon, point to F will add 2 decimal places. We covered format specifiers in a previous topic. So if I were to run this again, type 1, we show $0 and 0 cents. We're displaying 2 floating point decimal places. Now we need to make a deposit. That'll be the next function. We will define a local variable of amount equals accept some user input. enter an amount to be deposited. Again, when we accept user input, it's a string. We'll typecast it to a number, a floating point number, because we have to include dollars and cents. We'll add some checks, though, after accepting some user input. If our amount is greater than 0, we don't want anybody to make a negative deposit. Let's print, that's not a valid amount. Else, we are going to return our amount. So this function is going to return something. So within our else if statement, we will take our balance plus equals the deposit we're being returned with. This will add our deposit to our balance. Balance plus equals with plus equals the deposit we're being returned with. This will add our deposit to our balance. Balance plus equals deposit. Let's try it. Let's show our balance. Our balance is $0. We'll make a deposit of $100 exactly. Again, we'll show our balance after making the deposit. Your balance is $100. Let's attempt to deposit negative money. We'll select 2 to make a deposit. We'll deposit negative $420.69. That's not a valid amount. So we have a problem. We have a type error, unsupported operand for float and none type. So within this statement, within our deposit function, we're not returning anything. Let's just return 0. We have to return something. And within this if statement, we didn't return anything previously. We'll either return 0 or return a valid amount. Let's try this again. Let's make a deposit. I will attempt to deposit negative $420.69. That's not a valid amount. Our program's not crashing. That's good. Now we'll attempt to make a valid deposit. $50.01. Then show my balance. Your balance is $50.01. Okay, that is the deposit function. We'll work on the withdraw function next. We will create a local variable of amount, accept some user input, enter amount to be withdrawn. Our user input is going to be a string. We will typecast it to be a floating point number. We need to check to see if our amount we're trying to withdraw is greater than our balance. Users shouldn't be able to withdraw more money than what they have in their bank account. If the amount is greater than our balance that we have, we will print insufficient funds. Else if the amount somebody's trying to withdraw is less than 0, we will print a different message. Amount must be greater than 0. Else we will return our valid amount. So with our if and else if statements, we do need to return something. If we take one of these routes, we will return 0. We're not making any changes. Within our else if statement, where we select choice 3, we're going to take our balance minus equals the withdraw amount. Let's test this. Banking program. Let's show our balance. Our balance is 0. We'll make a deposit of $100. Show my balance again. Your balance is $100. Let's press 3 to withdraw money. Enter amount to be withdrawn. $1 kajillion. Insufficient funds. Yeah, no kidding. Let's attempt to withdraw money again. We shouldn't be able to select a negative amount. Negative $420.69. Amount must be greater than 0. Let's enter in a valid number this time. I would like to withdraw $49.99. That has appeared to work. We'll show our balance again. Your balance is now $50.01. Then we can exit by pressing 4 to exit. Thank you and have a nice day. The last few changes I'm going to make is that I'm going to enclose all of this code, our main portion of code, within a main function, just to encapsulate all of our variables and help with readability. We will define a function of main. Take all of our code within the main body of our program and place it within the function. I'm just going to select all of it and indent it. At the end of our program, we need to call a main function to run it. If you're familiar with the statement of if dunder name is equal to a string of dunder main, that means this program can be imported or run standalone. It is good practice to include this if statement. We discussed this in the previous video. If we're running this program directly, execute the main function. However, our variables of balance and is running, they're now enclosed within this local scope. These other functions have no idea what these variables are of balance, so we need to pass in our balance to those functions of withdraw and show balance. When we show our balance, we have to pass in our variable of balance. Same thing with withdraw. Then set up those parameters. Within show balance, we will have one parameter of balance. The same thing with withdraw. The last thing I'm going to do is add a little bit of text decoration around my program. Just to make it look nice. So I will print a bunch of asterisks. It's not necessary, but I think it'll look nice. Let's add some text decoration before and after the title of banking program. Also before our choice. Basically, whenever we print anything, we'll add some text decoration. Let's do that with show balance, our deposit, and within withdraw. Okay, let's run this one last time. Banking program. Let's show our balance. Your balance is $0. We'll make a deposit. $100.01. Show our balance again. Your balance is $100.01. We will withdraw money. Enter an amount to be withdrawn. $1,000. Insufficient funds. Let's try that again. Let's withdraw $50. Show our balance again, $50.01. Then press 4 to exit. Thank you and have a nice day. Alright everybody, that is a simple banking program you can write using Python. Hey everybody, in today's video we're going to create a beginner's slot machine program using Python. This project